I wanted to build a high volume feeder for my ducks and chickens, so I went to YouTube to get some ideas. It turns out this vertical PVC pipe setup is a pretty popular design and looks easy to build, so I did. But along the way, I discovered a couple of upgrades that I could make with some simple 3D printed parts. Stick around, I'll show you what I did. If you're not familiar with this design, it's simply a PVC tube that's filled with feed and that maintains a consistent feed level at the bottom where it's dispensed. Now there's a couple variations that I've seen. One just has elbows at the bottom, kind of looks like a big candy cane. Another uses a sanitary tee at the bottom where this part curves 90 degrees. However, this geometry creates an issue because of the angle of repose of seed, which is about 45 degrees. You know, how steep can you stack a granular material, and you'll end up with unnecessary spillage unless you install a baffle on the inside to lower the height of this opening here. So I'm going to use a Y fitting instead because the relative position between these two openings doesn't cause an issue and I won't need to put a baffle on the inside. I still will have an insert that I'm putting in, but for a different reason. Now under the Y is a cap, and all this area here is going to be filled with feed that will never be touched. Not only is it a waste of feed, but it'll sit there forever and get stagnant, and if some moisture gets in there, it'll probably get moldy. Anyone who's used chicken feed for any amount of time can tell you just how fast it can get moldy, even when it gets slightly damp. So I immediately took some measurements, jumped on my 3D modeler to make an appropriate insert. Here I'm using Tinkercad. It's a limited 3D package, but it is easy to learn and free to use. Now these holes in the side, that's not some structural element. I just do that to save on filament and printing time. This is just one of the parts that I designed for this feeder. Inserting this piece then keeps any feed from going too low down into the feeder where it wouldn't get touched anyway. And the slope on top directs all the feed to this point here, so that way there won't be anything stagnant in the rear either. During my research, I ran across a few instances where people had used the 3-inch PVC, and it seemed like in all of those cases they immediately regretted not using the 4-inch. So I'm going to do something I don't normally do, which is learn from other people's mistakes. Usually I just make them all myself. Now I was sure to go with what's called the drain pipe or sewer pipe and not the Schedule 40 pipe, which has a thicker wall. This is a thin wall. It doesn't need to be any thicker than this because it's not going to be pressurized. Also, it doesn't cost as much as the Schedule 40. It's lighter and easier to work with, especially if you're going to cut it by hand and not with a miter saw like I am. Because the pipe comes in 10-foot lengths, I'm going to build 2 of these, each 5 feet tall. Now these are filled from the top, and because I stand 5 foot 16 inches tall, I shouldn't have a problem filling these. However, some people may want to make theirs shorter if getting a bag or a bucket of feed up that high would be a challenge. Assembly is very easy. This is the insert that I printed, and I'll start by setting that down into the cap where I already have a piece of the 4-inch pipe that I cut to 3.5 inches long, and that'll act like a coupler between the cap and the hub of the Y. Now I'm not cementing these parts together. They fit pretty tightly without it. However, I am going to use a panhead screw that will run all the way through into that insert to keep it from rotating. And now the main tube, which goes on top, and again, this is just a press fit, no cement. Because this is somewhat experimental, I want to be able to take it apart and make changes if need be. If it turns out I start getting water in through this joint, then I'll go ahead and cement it. The common modification I've seen is some way to keep the birds from pulling the feed out onto the ground. Something like this downspout adapter, for example, or cutting a PVC cap in half and installing it on the end. But of course I'm going to design and print my own custom part. I think this is especially important with the ducks because when they eat, they throw food all over. In all of my years of existence, I've never needed to use the word voracious until I got ducks. At the same time, I designed a cap to go with this as well. Now this is going to be under a roof, so I'm not too worried about rain getting in, but with severe weather, I might want to cap it. And right now I don't have any issues with rodents, but if I do, I can cap this at night. Now for installing or mounting this whole contraption, there's the common practice of just using the galvanized perforated pipe strap. Not that this is some fancy 5-star chicken coop or anything, but I can get a much tidier look with a custom designed 3D printed mounting strap. And I designed these such that it'll hold this about 1/4 inch away from the fence or wall or wherever it's mounted, and therefore there's no interference when the cap, which is slightly larger diameter than the pipe, is put on. Because the bottom strap has to go over the hub where the diameter is slightly larger, this is a different piece that also has a slightly larger diameter. This is the first one that I built just as a test, and I had filled it about halfway, and now it's empty, and looking down in here, it appears that the birds don't have any problem getting all the way down in there to get the food, as there is not a single pellet left, just a little bit of dust. And so that sloped insert is working as intended. And also there is little or no feed on the ground, so that partial shield is either doing its job or the chickens are eating anything that spills out. Either way, it's all good. And the final piece that I designed is this funnel here. The small end is 4 inches, fits down perfectly inside that tube, and the top is 8 inches wide. And then I got this flat spot on the side here, and then that way, if you put it in up against a fence or a wall or something, there's no interference. And my printer ran out of white filament halfway through, and it automatically switched over to red. So that's why it's 2 colors, but it is 1 piece. So now I've got 2 of these, both 5 feet tall, and I'm curious to see how much feed they'll actually hold. And so I have my bin of feed that I weighed before, and then fill up my bucket here about 3/4 of the way and poured them in. And about 3 of those buckets filled this to the top pretty much perfectly. After doing the math using the weight measurements before and after, it turns out these 2 together hold 37.8 pounds of feed, which is right about 75% of a 50-pound bag. Not bad. If you're interested in building one of these and have access to a 3D printer, I've made the files available. Information is in the description. Also, there's an option to make these with a double Y for 2 access points. I have a file to print and insert that would work with that too. If you enjoyed the video or found it helpful, please give it a thumbs up, and thanks for watching.